This is Grayson. I'm presenting myself and Aiden's solution to the dining philosopher's problem. We decided to use C++ to write our program. We've got some include statements up here just for doing input, output, and handling strings. We've got thread and chrono for handling delays within our program as needed. We're using the standard namespace, so we specify that. We have some enum values just to make it easy to adjust at the top level of the program: hunger gained while thinking, hunger removed while eating, and a threshold at which to start eating. This is the philosopher class. It has several private attributes: the ID of the philosopher, the current hunger of the philosopher, the state of the philosopher, whether it's thinking or eating, the internal method getID, which just returns the ID. Same for getHunger, returns the hunger. SetHunger sets the hunger. SetID sets the ID. Ditto for setState and getState. We have some public methods. Public method eat, which takes in a boolean, which determines whether or not a log is created. It sets the state to 1 to indicate that the philosopher is now eating. We set the hunger to whatever the current hunger is minus whatever hunger we want to remove while eating. If hunger is less than 0, then we just set hunger back to 0 because hunger can never be less than 0. If we passed a boolean, then we just output that that philosopher is eating. We specify which philosopher it is, and we specify its current hunger. We then simulate how long it takes to eat. We sleep for 1/10 of a second. Then we go back to thinking after we finished eating. We have another method, think, which also takes in a boolean. We specify that the philosopher is now thinking. We add to the philosopher's hunger. If we passed true to this function, this method, then we output that the philosopher is now thinking and what its current hunger level is. We sleep for 50 milliseconds to simulate how long it takes them to think. If their hunger is greater than or equal to 100, then they've died of hunger. They've gotten too hungry. If that's true, we return true. Otherwise, we just return false. We have a public method that also returns the hunger. Default constructor takes no arguments. Default constructor that takes an ID and sets that ID. This is our main method. We keep track of how many times we've ran through the loop. We keep track of the number of philosophers. We prompt the user for a number of philosophers. We take in that number. We create that number of philosophers, put them in an array, and then we have our running loop. If we recompile and run this, I'm going to enter in 12 philosophers. You can see that the philosophers are thinking on and on and on. Once any of their hungers reach 25% or higher, they will start eating, and you can see now we've got some eating interspersed here within the thinking. Obviously, two philosophers who are sitting next to each other at the same time will never be eating. We keep track of the number of runs and just output it every 100 million just to make it easy to ensure that we can tell how long our program's been running for. We keep track of the first philosopher to eat for the current iteration of the loop and the last philosopher to eat. Then we go through every single philosopher. If the current philosopher's hunger is greater than whatever the threshold is to start eating, and nobody's yet eaten, then this is the first philosopher to start eating. This is also the most recent philosopher to start eating, and we have them eat. Otherwise, if the philosopher next to them is not eating, and if the philosopher on their left side, right, isn't eating, and the philosopher on their right side, which would be at most the 0th philosopher, isn't eating, then they eat. Otherwise, they just think. If the philosopher starves after thinking, then we return 0. We exit the program. Otherwise, if the threshold isn't high enough, they also start thinking. If they've starved to death, we return 0 and exit. Then we add 1 to the number of runs. And this program is just going to keep running infinitely. Whenever a philosopher is hungry enough, they'll just be eating, otherwise they'll be thinking. And you can see that none of the hunger percentages ever get above 30% with the numbers that we have provided up here, which is 1 hunger gained while thinking, 2 hunger removed while eating, and a minimum threshold to start eating of 25%.